Let's ponder for a moment. What if our sun suddenly went out? Whether it's just for an hour, a month, or an entire year, what impact would it have on humanity? Imagine the last photons from the sun's surface and the particles of the solar wind embarking on their final journey toward Earth. Unbeknownst to anyone, the heart of our solar system has ceased its operation. 8 to 9 minutes later, the sky plunges into darkness. Whether it's midnight or a sunny noon, the stark contrast becomes apparent. Stars twinkle against the pitch-black canvas of the sky. The moon, devoid of sunlight to reflect, disappears from view. Before the profound darkness sets in, the northern lights might briefly illuminate the sky due to changes in the Earth's magnetic field and disturbances in the ionosphere. However, the most alarming consequence is the halt of photosynthesis, leading plants and cyanobacteria to cease oxygen production. This poses a significant challenge for all living beings. An hour later, panic ensues on the daytime side of Earth. Global power and communication outages occur, temperatures drop, and the Earth's surface slowly cools while the planet's molten core maintains internal heat. 24 hours in, dawn remains absent, and chaos prevails worldwide. Governments struggle to regain control as humankind grapples with extensive power and water supply failures. Surface temperatures plummet to 5 degrees to 7 degrees Celsius, 41 degrees to 45 degrees Fahrenheit, a drop of 15 degrees to 20 degrees Celsius, 30 degrees Fahrenheit. As time progresses, certain plant species and microorganisms begin to perish. Oceanic inhabitants initially experience minimal change. After 7 days, darkness persists, and the average Earth temperature reaches -17 degrees Celsius, 1 degree Fahrenheit. In areas with tectonic faults, warmth persists, thanks to geothermal energy, preventing surface freezing. Most plants succumb to cold and darkness, while herbivores and heat-loving animals face the same fate. In the oceans, phytoplankton begin to perish, impacting shallow water inhabitants. As the Earth succumbs to extreme cold, the ocean's surface freezes, reaching an average temperature of -30 degrees Celsius, -22 degrees Fahrenheit. Ice blankets the planet, causing widespread devastation. Trees and plants perish, even conifers struggle without sunlight, and most life disappears. Surprisingly, resilient bacteria persist in their normal activities. Life clings to geothermal springs and underwater realms where the ice slows down cooling. Mass extinction unfolds, leaving only a few survivors near warm oceanic faults. 1 year later, Earth and its oceans are encased in thick ice. Professor David Stevenson predicts a further drop to -40 degrees Celsius, -40 degrees Fahrenheit, and speculates that only deep-sea life and some humans, relying on geothermal activity, may endure. Stevenson foresees Earth cooling for millennia until reaching -160 degrees Celsius, -256 degrees Fahrenheit, rendering traditional life impossible. The sun's gravity remains a constant, preventing celestial bodies from veering into space. However, the prospect of Earth colliding with asteroids or integrating into another stellar system exists, albeit as a distant and speculative outcome. While this scenario is largely fantastical, it serves as a thought experiment. The sun's actual future involves swelling into a red giant in a couple of billion years. Mercury and Venus will be swallowed, and Earth and Mars heated to extremes. 5 billion years later, the sun explodes, leaving a white dwarf at the solar system's center. Humanity's fate remains uncertain, pondering possibilities beyond the distant horizon.